Hello students, let us see one more excellent problem from CSIR-NET December 2024 question paper. So this question is excellent because it is using the concept of two subjects, statistical mechanics and quantum mechanics. You are using harmonic oscillator and you're using the Boltzmann statics. Okay, so it teaches you these concepts very nicely. So let us solve this problem. So you have a harmonic oscillator is given. So he says, what is the probability that the temperature T, the energy of the system will be less than 4 h cut omega? Okay. So we know this is harmonic oscillator energy En N1 plus half h cut plus N2 plus half 2 h cut omega. Now here N1 can go from 0, 1, 2 to infinite. Similarly, n2 can go from here 0, 1, 2 to infinite. But I need the energy should be less than 4 h omega. So this is possible only if I say this expression of energy, if I say this is equal to n1 plus 2n2 h cut omega, okay, and then you half h cut this one and this one here, so this is 3 by 2 h cut omega. Okay, so basically I can write the energy as n1 plus 2n2 plus 3 by 2 h cut omega, and now this energy has to be less than 4 h cut omega. So if I solve this one, this gives me my n1 plus 2n2 should be less than 4 minus 3 by 2, 2.5, that is 5 by 2. So this is the condition will be applied if I want my energy should be less than 4 h cut omega. Okay, now these are numbers. Okay, there are no fraction numbers. So n1 n2 can this sum this I'm writing this as a n1 plus 2 n2 5 by 2. Now n can be only 0, 1, 2, 3. Okay, so if n is 0, this is only possible when n1 is 0, okay, or n2 is 0. Then they are less than 5 by 2. Second case, n can be 1. So this 1 is possible when I say n1 is 1 and n2 is 0. So this is the second case. Third case also say I say n equal to 2. Now n equal to 2 possible when n1 is 2, n2 is 0. And this is also possible when n1 is 0 and n2 is 1. Okay. So these are the four possibilities will satisfy the limitation that energy should be less than 4 h cut omega. Okay. Now let us calculate the probability. Okay. So in order to calculate the probability, probability that energy should be less than 4 h cut omega can be given as a e power minus beta e n. Okay, of course en, and now there are four possibilities because we have to sum the probabilities of each option. And so here condition En should be less than 4 h cut omega, and then so automatically the choices of n1 and 2 also limited. Okay, and En is less than omega, then choice is also limited. So you can write here that n1 plus 2 n2 should be less than 5 by 2. And bottom you have to take all the states. Okay, total probability. Okay, sum of all the states z partition function. So you can go, it says n1 can go from 0 to infinite. Similarly n2 can go from 0 to n2 also can go infinite. Okay, that is e power minus beta en. Now let us solve this expression. on the top only there are 4 possibility. Now I can write this as alpha, beta. Now this is what this I can write. En should be less than 4 h cut omega e power minus beta, that is n1 plus 2n2 plus 3 by 2 h cut omega. Okay. Similarly, bottom also I can write summation n1 0, n1 0, n2 0 to n1 infinite, n2 infinite, e power minus beta n1 plus 2 n2 plus 3 by 2 h cut omega. Okay. Now just you have to solve with a simple solution using GP. Okay. Now this gives me, this solution gives me, I have to put the all the 4 cases. Okay, I am putting e power minus beta upon h cut omega by beta is kt is equal to alpha. So this become alpha power n1 plus 2n2 and alpha power 3 by 2 will be out. Similarly, here also alpha power 3 by 2 will come out. If I write this as a alpha, and you have a summation alpha n1 plus 2 n2. Okay, so condition varies here, variables already have written, and how it varies. Okay, so here this varies from 0 to infinite, and here you have a limitation en should be less than 4 h cut omega. Okay, so now let us solve it further, one more step. So now here this can be 1. Okay, so there are total 4 cases. So I can write this as a, this can be 0. So this can be, this can be 0, alpha power cancel. This can be 0, alpha power 0, alpha power 1. Okay, and 2 can be in 2 ways, 2 ways. So this will be 2, but two ways. There are total 4 cases. So this is, if you solve, you get this one. And bottom I can write this as a alpha power n1, n1 goes from 0 to infinite, and n2 goes from 0 to infinite, that is alpha square. Okay, and now this is a simple GP, so this has become 1 plus alpha plus 2 alpha square, and this is a alpha infinite terms, so this is 1 upon 1 minus alpha, and this is your 1 upon 1 minus alpha square. Okay, so the solution becomes, so the solutions becomes 1 minus alpha, 1 minus alpha square, 1 plus alpha plus 2 alpha square. Okay, now none of the solutions matching, so you can solve it further. So 1 minus alpha, so this I can write 1 minus alpha, 1 plus alpha. This gives me 1 minus alpha ka square, 1 plus alpha, 1 plus alpha plus 2 alpha square. So the option 4 is the correct answer. Okay, so you've seen I have used the Boltzmann statistics for the calculating the probability, and you have a harmonic oscillator. So this is a very nice problem. Okay, if you like the solution, subscribe my channel. Okay, thank you very much for seeing the video.